Hello. Unit 3, polynomials. So polynomials look like this. The x's need to have a power that is a whole number. They can't be fraction, they can't be negative. Okay. This term without an x is called the constant. Uh, these numbers that are attached to the x are called the coefficients. Coefficient. The x with the highest power, which in this case is 4, that's called the degree. So the degree of this function is 4 because that's the highest power. And the number, the coefficient attached to the degree is called lead coefficient. So the first topic is long division. First of all, whenever you see any polynomial, the first thing you should think about is rearranging it in degree order. So whatever your highest one is, so in this case it's 4, you're trying to go in order 4, 3, 2, 1, and 0. 0 means constant, just a number. So for this case, our 4 is this one, our 3 is this. Now 2 we don't have, so we don't skip it, just put a 0 in front of it. It's gonna help you so much. Then we have negative 3x plus 3. And same thing with the denominator. X squared is your highest power, so we start with that. There's no x, so we put a 0x and plus 2. Now to set up long division, you do it just like your normal long division. Okay, you write it all down. 2x4 plus x cubed plus 0x squared minus 3x plus 3. And that's being divided by x squared plus 0x plus 2. Long division, way easier than you think. All you're trying to do is make this first term equal to this first term. So what do we multiply to x squared to become, so that it becomes 2x4? 2x to the power of 4, you multiply 2x squared. And now, whatever you multiply to x squared, you multiply to everything. So that's that. 2x4 plus 2x squared times 0x is just 0x cubed. Plus 2 to the 4, 4x squared. Okay, like terms together. And then you subtract this, so all the signs flip. This gets cancelled. X cubed minus 0x cubed is just x cubed. 0x squared minus 4x squared is minus 4x squared. Then you bring the next term down, minus 3x, and you repeat the process. You're trying to make this first term equal to this first term. What do we multiply to make it equal x cubed? We just multiply an x. Okay, so this x multiplies here, it becomes x cubed, 0x squared, and plus 2x. So when you subtract that, this gets cancelled. This just stays because it's a 0. This becomes a negative 2x, so it becomes negative 5x. You bring the last term down, plus 3, and repeat the same process. Make this first number equal this first number. All you need to multiply is a negative 4. Negative 4x squared plus 0x, and then negative 4 times 2 is 8. These gets cancelled because it's a negative. You flip all the signs, this becomes a plus. You're left with minus 5x, and then 8 plus 3 is 11. Okay, so this is your answer, your quotient, and this is your remainder. How you write it down is this equals to your quotient, whatever answer you got, because it got fully divided. The thing that didn't get fully divided is a remainder. So how you write the remainder is 5x plus 11, and still it's not fully divided, you just still keep dividing it. So you put your divisor under it, and that's how you write an answer. Okay, next up, remainder theorem. Very easy stuff. Whenever you have uh, your divisors in the form of x plus or minus a number, okay, the x can't have anything attached to it. Can't be 2x, it can't be x squared, nothing attached to it. If it's just plain x plus or minus a number, then you can use remainder theorem. And also that's the same restriction for synthetic too. For synthetic division, I get to that, but the dividing thing has to be in this form, x plus minus a number. So with remainder theorem, all you do, you take this number, you flip the sign, so it becomes plus 1, and you plug it in to this equation. And whatever answer you get, that's your remainder. So this becomes 1 to the fourth minus 2 of 1 to the third plus 4 of 1 squared plus 6 times 1 minus 12. So that's just 1 minus 2 plus 4 plus 6 minus 12. The positives add up to 11, the negatives negative 14. So your remainder is negative 3. That's it. Now we can use that remainder theorem to factor any polynomial. How we do that? Well, this is called the factor theorem or the integral zero theorem. Remember when we have a quadratic like this 8x minus 6, and you multiply the 2 and negative 6 to get negative 12, and you see what two numbers multiply to negative 12 and add to 8, right? And something like that. That's the same thing. That's all factor term is. You take the first number, you take the last number, you multiply them. 2 times 6 is 12. And then you write down all its factors. Positive, negative 1, 2, 3, 4, 6, 12. Okay? Now what factor theorem says, the factors of this must be uh, one of these. So you can use, so now that you know that, what do you call it? One of these has to be the factors. You can use remainder theorem to verify that. So let's pick a number. Let's pick 1, for example. Okay, if we plug 1 in, you get 2, 1 cubed minus 1 squared minus 7, 1 plus 6. So that's 2 minus 1 minus 7 plus 6. So that's just 8 minus 8. 2 plus 6 is 8, minus 7 minus 7, 8, which is 0. So now that we know we got a remainder of 0, that means this thing is perfectly divisible when we plug in 1 for our remainder term. So remember, but one thing you remember, you flip the sign. So we can confidently say that a factor of this equation is x minus 1 because we plugged in a positive 1. Okay, now that we have that, now we can use division. Okay, we can divide this whole thing by this, and we're gonna be left with some sort of quadratic, and we can factor a quadratic, right? And if it was if instead of cubic it was a quartic or a quintic, then we would just repeat this factor theorem twice or thrice, as many times as we need until it turns into a normal quadratic that we can factor. So now the easiest way to do that division is called synthetic division. So we're right now trying to find uh trying to divide it by x minus 1 because we know it's one of the factors. So with synthetic division, just like remainder theorem, you flip the sign of the divisor, you put it outside, 1. And synthetic just means without x. We're just ignoring all the x's and just using all the numbers that are attached to them. So we write all those down in order. Remember, always put them in order. This is already in order. And also, whenever you can, before doing any factoring, factor any number or a negative out. if you can. So if your question was instead of this, it was 4x cubed minus 2x squared. Let's do negative plus what do you call it? 14x minus 12. You can see that a 2 can be factored out and this negative at the start. Whenever there is a negative at the start, factor that out too. So you factor that out and oh, 2. And that should always be your first step. Okay? That should always be your first step. In this case, we don't have to do that because there's nothing we can factor out. So now we write these numbers down in order: 2, -1, -7, and then a 6. And how synthetic division works: the first number comes down, then you multiply these 1 and 2, that numbers goes here. So 1 times 2 is 2, then you add -1 plus 2 is 1. Then the same step repeats. You multiply this and this, 1 times 1 is 1, plug it in here, add them. It becomes -6. Same thing, multiply these, plug it here, -6, add them. You get 0. And how your answer, this is what synthetic division looks like. It should be like it should take you under a minute. And how you write down your answer is, it's reverse order. So you know how we wrote these in order from 3, 2, 1, 0. Now it's just reverse that. Or well, I guess not. You just start here. This is your remainder. Okay. Remember, we used remainder theorem and we found our remainder was 0. So that's how we know we did it right, because it's perfectly factorable. Then we go to constant, which is x0, then x1, x2, and so on and so forth if we had them. So now when we divide x minus 1, we're left with 2x squared plus x minus 6. Okay, and now we know how to factor that. It becomes what two numbers multiplied to 12 add to 1? Well, that's 4x and -3x minus 6. Factor the 2x out. 2 minus 3x plus 2. You're left with 2x minus 3 x plus 2. So this whole thing factors out to x minus 1, x plus 2, and 2x minus 3. And that's how you factor out any polynomial. Next up, graphing. So graphing's also way easier than you think. There's two families of graphs. One is the odd powers, one is the even powers. The only thing that matters really is the end behaviors. So you know how a normal graph y equals x looks like when it's positive, and y equals negative x to the power 1 looks like this. Okay? So the end behavior of these graphs is, this is up in quadrant 1 and down in quadrant 3. This is up in quadrant 2, down in quadrant 4. Okay, and with quadratic, you know how that looks. Up in 1, up in 2, if it's positive, and if it's negative, then down in 3, down in 4. Okay? And the this is really easy. The higher the power, the flatter it gets near the x-intercept. Okay, so x cubed is gonna look like this. It just goes flat and up. Negative x cubed is gonna look like this. The end behavior stays the same. It just gets flatter. Okay, with x to the power of 4, instead of being a quadratic like that, it just goes like that. And oh, it does touch the x-axis. Wait, wait. Okay, it looks like that. You know what I mean. And then if it's negative, it looks like that. And with we only go up till 5, so I'll just show you what 5 looks like. It's just even flatter. like that. And then if it's negative, it's just the end behavior stays the same. It just gets even more flatter. Okay. Now let's graph this thing that we just factored. 2x cubed uh, minus x squared minus 7x plus 6. So with graphing, the first thing you do is you factor it, which we already did. We got x minus 1, x plus 2, and 2x minus 3. You can, even if you just had this, you could graph it, because the only thing we really need from this equation is its degree. The degree is what defines it, like what it looks like, the end behavior of it, not what it looks like. The degree, so if I draw my graph, the degree is 3, and the a value is positive, the leading coefficient is positive, so we know it's gonna be up in quadrant 1, up in quadrant 1, down in quadrant 3. Okay, now all we need is our x-intercepts. Okay, x-intercepts are, one of them is 1, other one is -2, and the third is 3/2. So let's just quickly graph that. -2, 1, 3/2. Okay, so you know it starts here and ends here or whatever. So what you do, you start here, and based on the power, this is what multiplicity is. You look at the power of each of these x-intercepts, and that's how the graph behaves near that x-intercept. So right now all of them is just power of 1, so it's gonna act like this. It's just gonna go straight through. So right now it just goes straight through. The other one, it goes straight through. The other one, it goes straight through. Okay? And yeah, because it's going straight through, it's also changing direction. So it's pretty intuitive. So now, if instead of this, what if my power for, let's say, x plus 2, it won't be the same equation, so just ignore that. Okay? What if my power for x plus 2 was 2? Okay? And also for 2x minus 3 was also 2. Okay, so now using just this we can figure out the degree. We add these numbers. Okay, 2 2 1, because there's 2x's in here, 2x's in here, 1x in here. So how many total x's do we have? 5. So our degree is 5, and with degree of 5, and because it's positive, right, there's no negative outside, otherwise the negative would be factored out. We know it's the same thing. It starts here, ends here, because it's a positive odd degree. So same things here and here. Let me just delete this graph real quick. But now what changes is, uh, here at 1, it's still gonna go straight through because it's a degree of 1. But at the other ones, now it acts like a quadratic, so it's gonna bounce. Okay, so it starts here, -2, it's gonna act like a quadratic. It won't go through it. At 1, since it's still degree 1, it will go through it. And then at 3/2, its power is 2, so it's going to act like a quadratic again. So it's going to look like this, and then act like a quadratic. And see, it ended here. Okay, so that's it. You plug in all your x-intercepts, you find your degree, and see what your end behavior is. And then based on the powers of your factors, that's how you see how your graph's gonna look like. So let me just do, actually, let me give you a question to try yourself, because this is pretty intuitive. And yeah, that's it for polynomials.